Hello, everyone, and welcome to our closing keynote. I am so excited to welcome you all to this final session of the 2022 MiCorps Annual Volunteer Lake and Stream Monitoring Conference. We have had, from all accounts and all the feedback I've gotten so far today, a very successful conference, even with the switch to online. And as we've mentioned throughout, we've been recording all the sessions. We have links to those recordings for you. Give us a little time. We need to clean them up because we don't want to, include all the chatter at the beginning as we're getting things set up and that kind of thing. So we'll do a little editing, get them up on our website, and then we will send you instructions on how to access those. I don't want to take up too much time, so I'm going to jump right into introducing our closing keynote speaker. I'm really excited to have Jake Lemon here with us. Jake is the Monitoring and Community Science Manager for Trout Unlimited. And a little bit about Jake: he has over 10 years of experience in conservation, private and nonprofit sector. He has a bachelor's degree from the University of Indiana in environmental science. And he has experience in developing and implementing citizen science and monitoring programs, facilitating stakeholder groups, and communicating technical information to the public. So he's definitely our kind of guy. As TU's Monitoring and Community Science Manager, he supports monitoring efforts to aid in the protection of cold water resources, project prioritization, and project evaluation. And I am always excited to hear about what new projects he's working on, what Trout Unlimited is doing, especially in Michigan waters. They're probably more active than a lot of us even realize. So as always, if you have questions for Jake as you go on, as you listen to what he has to say, pop those into the chat. I'll be moderating some Q&A after his presentation. And with that, I'm going to hand it over to Jake. Thanks, Jake.
All right. Thanks, Joe. Thanks for the introduction. Hey, everybody. Thanks for having me out today for the MiCorps conference. As Joe said, my name is Jake Lemon. I'm actually based in Rockford, Michigan, which is just north of Grand Rapids. And I've been with TU for over 10 years now. I started with working for the Colorado Council of TU. And then moved to our eastern region based in Pennsylvania in 2014 and then to Michigan in 2018. But throughout that whole time, all of my work has had, some association with volunteer monitoring. I spent a lot of time working with volunteers on water quality and habitat and biological monitoring throughout all of those regions. And so today, I'm just looking to, kind of provide my perspective on the benefits and strategies associated with volunteer monitoring. This presentation isn't meant to be comprehensive, but a comprehensive look at the benefits and strategies, but merely just share my perspective and some of the things that I've learned along the way. Briefly, I just want to introduce Trout Unlimited in case there's anyone out there who's not familiar with our organization. We're a nationwide nonprofit organization that works to protect, reconnect, and restore cold water fisheries in their watersheds. So basically, we work where wild and native trout are and do things like stream restoration, stream protection, advocacy around cold water fisheries issues, things of that nature. And we're organized in local chapters that are spread throughout but really the whole United States. I think in Michigan, we have something like, I want to say like 20 chapters, maybe a few more than that. And these are volunteer-led chapters, operate a lot like a watershed association in many ways. We have our state councils, which sometimes have staff, sometimes don't. In Michigan, we do have a really high-functioning, great state council that works on statewide issues, both restoration and advocacy. And then we have national organization staff, of which I'm one of those. And so we have field staff, I want to say about 350, maybe a few more than that at this point, all over the country, from working in places from Georgia to Maine to Alaska and California and pretty much everywhere in between where there are trout. Here in Michigan, I think we have about 10 staff now. We have a growing program in Michigan that does a lot of stream restoration work and monitoring and research. And so you'll see a few examples of some of the monitoring side of things there. But With that, I think before we jump into some of the benefits and strategies component, I just want to provide a little bit of, I guess, background or context on, how I view citizen science and some of the history of citizen science that gets us to where we are today. So, the public perception, I think, of science, of a scientist, often, falls into like a person's in a lab with flasks and pipettes working, with chemicals and things like that. Not, I'm guilty of promoting these stereotypes when my son asked to be a mad scientist for Halloween last year. And, this stereotype, I think, does hide the real diversity and accessibility of science in its various forms. And in my opinion, if you're a person who looks at the world, asks questions about it, and then looks to answer those questions through the scientific process, you're a scientist regardless of credentials. And, historically, most scientists were amateurs. The credentials needed to carry out scientific research have changed over time. And many renowned scientists from history, this was a hobby, or this was a side project for them. Gregor Mendel, who's known as the father of modern genetics, was a monk. Antony von Leeuwenhoek, who discovered microorganisms, was a cloth merchant. Eunice Foote, who put together experiments that first showed that rising CO2 levels would change atmospheric temperature, was an activist and a homemaker. And so, it wasn't really until, the 1800s or so, and when the professionalization of science occurred. The term scientist wasn't even coined until 1833. And, this kind of came along with a number of scientific societies, scientific journals, opportunities for advanced research and education. And while this professionalization of science brought, a certain level of rigor to science, scientific research, accountability, facilitated collaboration and information sharing, and a lot of the scientific advances that we've seen in that time, it was really I think a big step in sort of the development of science as a tool for society. And, in the modern area, citizen science, volunteer monitoring really relies on the collaboration between professional scientists and then, the amateur scientists. Just a quick, brief interlude to talk terminology. There's lots of terms out there for citizen science, and I tend to use them interchangeably. Often, citizen science, community science, volunteer monitoring. TU has used angler science in the past, crowdsourcing, amateur science, public participation, and scientific research. I tend to use these interchangeably. TU recently rebranded our I guess, volunteer monitoring into a community science effort, believing that to be a more inclusive term that really speaks to our interest in working with communities on collaborative initiatives that benefit cold water species. And so community science is the term we use most often at TU, but I tend to jump around between different terms. As many of you probably know, community science or citizen science really was started around, bird science. So one of the earliest modern citizen science programs started in 1880, and this was the North American Bird Phenology Program. So basically, they were tracking bird migrations, when birds were showing up in particular areas at particular times of the year. Of course, the Audubon's Christmas bird count is the longest running citizen science program at 123 years now, and many of you probably have heard of that or maybe even participate in that. And there's been weather information crowdsourcing going on as far back as 1890. And so, citizen science has been around in its current form for some time, but there's really been a modern resurgence or major increase in the amount of citizen science programs out there in the ways that different groups are leveraging community science for the work that they do. And really, this was driven by a few different things. A big one is technological advancements, the internet being a big one, facilitating communication between research and the public and citizen scientists, also facilitating data management, web mapping and data visualization, just a lot of tools there that support the community science work that we're all doing. And alongside of this, there's been more and more state and federal buy-in and using volunteer-generated data. And the MiCorps program is a perfect example of this, where the state is investing in a program that supports volunteer-generated information to inform their management and the protection of water resources in the state. And so, I think it's obviously greatly expanded our capacity to collect useful data. I think I heard Jo this morning say she did an assessment looking at the sources of available water data in the region, and the vast majority of it is generated by volunteers. And so without this resource, obviously we'd have less information upon which to make good decisions about how we manage our resources. So jumping into the benefits of community science, first talking, from the sort of the social outcomes. Obviously it facilitates a lot of learning, facilitates learning about your local environment, especially. And so you all have experienced this by going out to your local lake or your local stream and collecting these data and collecting it over time and seeing how things may change due to certain climatic factors or seasonally, things like that. It's really a great practical hands-on way to engage with your local environment and learn about it. And similarly, citizen science provides students with meaningful opportunities for learning and the ability to learn while collecting data that has practical applications to questions that they have about their local environment. And I'll show some examples of this later on. Finally, it also improves general science literacy. So by engaging folks in the scientific process, you're giving them a more hands-on understanding of how science works, how research works, and just improving that general science literacy. It also, we've seen in many of our programs, engagement in community science projects often leads to engagement in relevant policy issues. It can often be an entry into engaging in advocacy and advocating for your local resources and your local waters. I also think a really important benefit of community science is the connections that it draws between researchers and the public. Scientists are sometimes guilty of kind of working in their silos and exploring their interests with maybe less regard to the needs that are out there in the communities than we should have. And so by connecting scientists with the public through programs such as these community science programs, we can facilitate public input into research and management that supports the issues and the questions that we're seeing in our local environment and on the ground. And so I think that's a huge, huge outcome of citizen science. And then finally, helping bridge the gap between science and society. I think we've all seen a growing distrust of science in our society. And so I think by better engagement of the public in the scientific process, we can foster more trust and help bridge that gap. So thinking about the conservation outcomes, I'll kind of lay these out with some brief introductions, but then I'm going to follow it up with some case studies that sort of illustrate these different conservation and many of those social benefits as well. So in the conservation side of things, early identification and tracking of emerging threats. So by collecting regular data, we are giving ourselves a better foundation upon which to understand how emerging issues or emerging threats are affecting our local resources. If we don't have the data to inform baseline data collected in advance of these emerging threats or relevant baseline data, it's really hard to track what's happening in our local streams and rivers. Informing management and protection of water resources. I think this is a major, from what I understand, is a major goal of the MiCorps program. And so if we don't really understand the status and condition of our water resources, we're already behind the curve in regards to making data-driven and quality decisions on their management. And so having this data is integral to being able to manage these resources. Monitoring the effectiveness of restoration and management. So groups like Trout Unlimited were out there doing restoration work throughout the country. And it's important for us to monitor the effectiveness of these projects in order to adapt our strategies, as well as communicate the benefits of the work that we're doing. And so I'll provide examples of that. And then project prioritization. There's limited resources out there to implement conservation projects. And so it's important for groups like Trout Unlimited to spend time prioritizing spend the time that we need to prioritize projects that are going to have the maximum conservation benefit for the resources that we're putting into it. And more often than not, this requires data collection in order to collect the information necessary to make these determinations and have that scientific underpinning for our decisions as to where we put our resources. So with that, I'm going to jump into just some case studies, displaying some of these benefits. So when I moved to Pennsylvania, I lived just outside of State College, where Penn State University is located. In 2014, I took over TU's shale gas monitoring program. So many of you may recall hearing about the shale gas boom that occurred in places such as Central Appalachia in the 2009, 2010 roughly time period. And as this industry that, this huge industry was moving into communities that had never seen anything like this before, there was a lot of concerns for the potential impacts on water quality, on quality of life, and, all of that. And so Trout Unlimited in Pennsylvania designed a program that, very similar in some ways to MiCorps, where we provided training and technical support to our chapters to set up local water monitoring programs aimed at identifying impacts from shale gas related development. And so we provided training, we provided equipment, we helped with data management, that whole thing. And over the years through that program, and it's evolved over time, we've trained, I think about 1,500 volunteers, maybe closer to 2,000, collected data at hundreds of sites, and we've submitted about 350 or 400 complaints to state agencies as to pollution issues, water quality violations, failed or lacking erosion controls, things of that nature. And so many of those have resulted in notices of violation and stop work orders in some cases, and fix-it orders, things like that. And really the whole thing was, the state agencies did not have the capacity to comprehensively monitor this huge industry. And so it was up to the citizenry to be the extra eyes and ears on the ground. And so it was about knowing what to look for, how to document it, and how to effectively report it. And I think we showed a lot of success in that. And really the end product being mitigating the impacts that the industry had on the environment. So many of these issues that we documented and reported either would not have been identified or would have been identified much later, leading to more degradation of water resources. And so it's a pretty large, big program spanning Pennsylvania, West Virginia, and Virginia. And as the shale gas industry sort of slowed down, there was some rising or lowering oil prices, around 2014, 15. The program shifted to looking, more at pipeline issues, and then even highway construction, and starting to adapt to other emerging issues that were arising in the region. And we kind of helped develop this base of engaged citizens who had a good understanding of their local water resources and some of the ways that they can be degraded. And this has led to, a huge increase in advocacy around water quality issues in places like West Virginia. And we've really seen this program as a stepping stone for many of the, really effective water advocates in that region, which has been really, really exciting to see. And so with that, I think I'll jump to the next case study. So another program that I help manage at Trout Unlimited is our Enviro DIY program. So basically through this, we're providing training and technical support to our chapters, our watershed groups and partners to deploy and maintain and utilize data from real-time continuous water quality monitoring stations. So think something like a USGS station, only a smaller footprint, smaller cost, lower cost, and designed to be maintained by trained volunteers. You can see a picture of what the station looks like from the shore here. They're solar powered. They send data through the cellular network to a publicly accessible online database. And one of the first stations, we've deployed about, I think, 35 stations now in Michigan. One of the first ones that we deployed was in the Buck Creek watershed. Buck Creek is a tributary to the Grand River and in Granville, sort of the southwest portion of Grand Rapids. And it's an urban stream, but one that does support trout. And pretty quickly upon deploying this station, we started seeing some interesting data. This station will monitors temperature, stream depth, so like a gauge height, and conductivity. So conductivity is the ability of water to pass an electrical current. It's it's driven by dissolved ions in the water. So it's measuring lots of different things. It's not measuring just sort of one specific thing in the water. And every stream has a baseline conductivity. Even 100% undisturbed forested watershed will have a conductivity those cases driven by the geology of the watershed. So, a high groundwater influenced stream in Michigan may have a conductivity of somewhere like 150 to 300 microsiemens per centimeter. A small headwater stream in the upper Shenandoah River in Virginia that has very little groundwater influence I've seen data as low as 15 microsiemens per centimeter. And, other land use factors can influence conductivity from, just industrial development, road de-icing salt applications, agriculture, things like that. And pretty quickly upon deploying the station, the friends of Buck Creek noticed that they had elevated conductivity in the stream. They had base load conductivity fluctuating somewhere in the 1,000 to 1,750 microsiemens per centimeter, which is fairly high, and spikes going up to 3,500 to 4,000 microsiemens per centimeter. And it was pretty clear early on that these spikes coincided with snowmelt events that were happening in the watershed, which kind of pointed the finger towards de-icing salts as the culprit. The primary contaminant of concern in regards to de-icing salts is typically chloride. It is which is regulated by the state. And the Friends of Buck Creek took it upon themselves to do some further investigation to try to understand this issue and inform, what could be done in the watershed to mitigate this problem. And so they actually partnered with a high school chemistry teacher at a local school. And he and his students designed and implemented a synoptic sampling event. So basically, they went out and sampled, I think, 25 different sites, maybe 25 different sites throughout the watershed over the course of one day. So this was during the winter, but during base flow conditions, with the goal of seeing if they could find hot spots. Where are they seeing, and they were analyzing for both conductivity and chloride. Where are they seeing super high conductivity? Where is maybe conductivity a little bit lower? Just to try to help to hone in on where the issues might be most occurring in regards to de-icing salts. And in that graph, you see sort of in the top center, this is showing conductivity at all of those sites. The blue dots were main branch Buck Creek sites. The red dots were tributaries. So you see some tributaries were lower. We had one that was quite a bit higher during base flow conditions. And the plan is to follow this up with additional synoptic sampling events during snowmelt conditions to try to capture some of those spikes. And the Friends of Buck Creek are already using this data and communications with like local municipalities They hope through these synoptic sampling events to identify some hotspots and maybe start to work with private property owners who are managing large parking lots, things of that nature. And so great actionable data. And also it's just so awesome that it's happening because of high school students who are going out there and collecting this information and actually presenting it to stakeholders and things of that nature. So a pretty cool project. Effectiveness monitoring. So the example I have here is, well, TU spends a lot of resources and time working to benefit aquatic organism passage. So this is basically on rivers and streams, doing projects that enable fish to access the varied habitats within a stream network. So things like dams or undersized culverts can prevent fish from moving basically downstream of the dam or the culvert to the upstream portion of the stream. And this can prevent fish from accessing spawning habitat, accessing cold water during the warm summer months, so getting to these thermal zones of thermal refuge, can prevent, good genetic, mixing of these different populations that can actually genetically isolate portions of the stream. And so it's an important strategy that we employ to benefit trout populations. And the photo you see here on the left is basically an after photo where we had an undersized culvert that was replaced with a structure that allowed fish to pass. And so this is on Little Lyman Creek, which is in the Cross Fork watershed of north central Pennsylvania. And in this watershed, we've been doing with volunteers red counts for the past, probably 8-9 years. And so reds are the basically the gravel nests in which trout spawn. And through these red counts, we literally have volunteers walking every mile of the river network, basically taking GPS points of all the reds that you can spot, because they are visible when they're freshly made in many circumstances. And so the maps you see here on the right, the before and after. The red dot is on the left, and the red dot here on the left and the green dot here on the right are the location of that replaced culvert. You see on the left, much fewer reds. On the right, a heck of a lot more reds. So a good indication that there was some impact here. Now, keep in mind here that there are year-to-year conditions that can affect spawning, and I think I took the years out of here. I think the before was 2013, the after was 2015. 2015 was a high water year and a year where we had more spawning across the entire watershed, but we had conducted red surveys in a bunch of control streams where there was no management action taking place throughout these times. And while we saw an increase in spawning in all these streams, the rate of increase was 3 times that at the site of Little Lyman Run. So just a great example of showing the outputs of a potential project and creating data with the help of volunteer scientists that has great implications to support the work we're doing, both with funders and with partners. So something I spend a ton of time of thinking about is project prioritization. So again, helping us decide where it's best for us to spend our resources. And I've done a lot of work with our chapters and with our partners, collaborating on monitoring projects that involve volunteers to help us collect crucial data to aid in this prioritization. So the example I wanted to share here is in regards to climate refugia. So trout need cold water to complete their life cycle. And so a major concern for Trout Unlimited is climate change. So if we have increased air temperature, that has implications for water temperature, which has implications for trout populations. And there are some nice resources out there. This is the USGS FishViz model. They're basically regional models that predict, where we'll have suitable temperatures for trout under future climate change scenarios or future conditions. And while these models are really helpful for sort of broad scale prioritization, once you zoom into a particular river or stream, they really break down and start to lose their usability. And a lot of that is because at these broad scales, it's really hard to factor groundwater influence into our understanding of how stream temperatures might respond to climate change. And we know here in Michigan that groundwater, especially the lower peninsula, groundwater influence is what's driving where we have good wild and native trout streams. So understanding the nature and geographic extent of this groundwater influence is critical to making good conservation strategies. And one approach to doing this is by simply deploying in-stream temperature loggers. You see a picture of that here on the top right. So basically these are put in a stream for a given period of time, either a summer season or a number of years, and they log data at usually hour intervals. And then also corresponding air temperature sensors on nearby adjacent areas to the stream. And basically using these air temperature and without getting too much detail, using this paired air and water temperature, we can better factor groundwater influence into these climate change models to understand, will these areas support cold water fish species in the future? And so I'll provide a couple examples here. So a few years ago, I helped develop a study on the Upper Shenandoah River, working with our chapters there to employ this paired air, water, and temperature monitoring approach. And so this is one of the focal areas where we did this. It's the dry river, and it's an area where TU is spending a lot of resources doing river restoration. And the map you see down here in the bottom right, this is one of those regional models I was talking about. And so basically, this is modeling the likelihood of brook trout occurrence in 2087. So red is 0 to 10%, orange is 10 to 20%. So it looks pretty awful for brook trout in that watershed. And so if that's the case, we needed to know that so that we can better put our funding and our resources and our people resources into places that are going to sustain trout into the future. But that being said, we knew that groundwater was really driving the good conditions for trout in this watershed, and this model wasn't necessarily capturing that. So we deployed throughout the area. Actually, it was closer. There were 60 sites in this region. We had another region that I think we added another 30 sites. So we worked with something like 35 or 40 volunteers who were trained how to deploy and maintain these loggers. And we had put out this huge network of them. And just a basic of the results, the map here on the left is current conditions. So basically think blue dots mean good for trout, red dots are bad for trout. So current conditions, temperature-wise for trout in this watershed, pretty good other than this one spot, sort of outlier spot up here in the headwaters. USGS actually did the modeling of the data and ran a number of scenarios. They ran scenarios of 1.5 degree increase Celsius in air temperature, 3 degree Celsius increase, and a 5 degree increase. They also ran different models on how sensitive groundwater would be to those changes in air temperature. So if air temperature increased, would the groundwater temperature also increase? And so they kind of played with this and different sensitivities. And so there were a bunch of different maps and outputs, but what you're seeing here in the middle is basically the most dire output that came out of this. This is a high groundwater sensitivity to increases in air temperature and an increase in air temperature of 5 degrees Celsius. So if we get an increase in 5 degrees Celsius, we're going to have some problems in addition to losing trout streams. So this is a pretty dire scenario, but still, even under this conditions, with taking groundwater influence into account, you see that while we lose this bottom section of river in regards to good thermal habitat, the whole upper section of the river, we're still sustaining suitable cold water temps for brook trout. And so again, can't overstate the importance of this to both prioritizing where we do work and then showing our partners and funders that we have a firm scientific underpinning for why we're doing work in these areas. And so there's other methods using these paired air water temperature sensors that actually allow us to also get at the depth of groundwater. So the idea being that deep groundwater resources will be more resilient to increases in air temperature than shallow groundwater resources. And we're currently piloting some of these efforts in different areas around the country. We have a pilot going on right now that includes California, Oregon, Idaho, Wisconsin, and then the White River watershed in Michigan. And so we're kind of we're basically right now we're developing resources that will enable our chapters and partners to implement these types of studies and easily analyze and create usable data outputs with this paired air water temperature data. And I see this being a great opportunity for volunteer citizen scientists to contribute meaningfully to cold water conservation and watersheds around the country, because this is just such useful data. And it's the structure is in development that will enable groups to collect it and even analyze it themselves and interpret it themselves. So I'm really excited about this project and something that I see growing in the coming years. So lots of info there. I think I am going to change direction here a little bit and start to talk about a little bit about strategies in regards to some additional strategies in regards to volunteer monitoring. And specifically, I thought I would dive a bit into the process of developing a volunteer monitoring study design. Prior to developing a monitoring program, it's essential to think through the steps necessary to create data that will meet your objectives. And involvement in programs like MiCorps supports a lot of, supports this and supports the steps of the study design process. But I thought it might be useful to lay this out so that groups could have it in the back of their mind as they maybe identify other areas or other questions they want to answer with their monitoring. I should mention that the process I'm going to lay out was developed by a group called the Alliance for Aquatic Resource Monitoring, which is at Dickinson College in Carlisle, Pennsylvania. They've been doing citizen science volunteer monitoring for decades and created this really nice resource and training resource guide and training for assisting watershed groups with developing studies designs. So why should you develop a study design? Like I mentioned, it's really about focusing your monitoring efforts on a given goal and making sure that the resources that you're spending on monitoring are appropriate and are going to accomplish the things that you want to accomplish. It also facilitates clear documentation of your methods and QA procedures so that you can communicate the quality of your data to data users and partners, and also supports the continuity of programs through personnel changes. So by having all this written out and detailed, you can support sustainability of your programs. So basically, excuse me, Alarm study design process, and I borrowed heavily from that here, is basically designed around answering a series of questions. And this, I'm providing a general overview of this, or we can dig into this a lot deeper, and I'd be happy to share some of these resources after the fact. But the first question is just, what are your organization's major objectives? What are you trying to accomplish? What is your mission? What is your geographic focus? Just making sure that you have a firm understanding of that will underpin everything that you're doing. And secondly, why are you monitoring? Generating background info on your watershed. So what's the story of your watershed? I do a lot of work in the White River watershed in West Michigan. And when we were first kind of getting into working in this watershed, I think I spent probably a good year and a half just pulling together the various data that was out there for this watershed, including MiCorps data, talking to stakeholders, talking to folks who have been working in this watershed for years and leveraging their historical knowledge of what's going on and what the needs are in that watershed, just pulling together the existing information just so you can best identify and prioritize what kind of concerns you have about the particular watershed. And then based on those concerns, what are the questions that monitoring could help answer? And this will help you kind of get to the point where you can identify what information you need. So these questions could be very general, things like, what is the health of our watershed? Or they could be very specific, like, how is this specific point source pollution source impacting stream health? Or where do we have good temperatures for cold water fish species? The questions can vary in their specificity quite a bit. Step 3 is one I like to highlight is just like being super, super important. How will you use the data? So who is your data audience? Who do you want to look at the data that you're generating and then, initiate some sort of action to benefit the concern that you have? If you don't identify who your audience is and what your targeted action is, it's really impossible to be sure that the data you're collecting is going to have the outcome that you're looking for. And so your data audience could be, a state environmental agency, for example. And in that case, whoever your data audience is, you need to bring them into your planning process at this point to ensure that you're collaboratively identifying, developing a study design that's going to meet the requirements of the target audience for your data, to ensure that they will be comfortable and will be able to use the data in the way that you're hoping it will be used. So identifying who you want to use that data, what the targeted action is going to inform everything else that you do pretty much. What will you monitor? So what are the parameters that will support the question that you have and the targeted action you're looking to assess? So if you're wanting to understand road salt contamination in your watershed, you might look at chemical parameters like chloride. If you're wanting to understand where you have good temperatures for trout in your watershed, physical parameters like temperature could be important. A general understanding of the health of your watershed, biological parameters like macroinvertebrate assessments are really useful for getting at sort of the general health of the watershed. So this is a phase where it's nice to have some technical support in the mix through an organization like MiCorps or Trout Unlimited or other service providers that help out with volunteer monitoring groups to make sure you're picking parameters that are going to answer the questions that you've previously identified. How will you monitor? So what methods will you use? This is going to be dependent on what you answer for step 3, who your data audiences are. So if you're working with a state agency, they may have prescribed protocols they want you to follow. If you're monitoring nutrients for educational purposes, you might be able to use a low-cost kit that you buy online. If you're looking for those data to be used by a state agency for, enforcement, for example, you may need to send it to a certified lab. So it's really gonna, how you want that data to be used will dictate the methods and protocols that you use. Where will you monitor? So this is basically where are your sampling sites? And the question will dictate this. So if you're looking at general watershed health, maybe you're distributing sampling sites throughout the watershed and the major tributaries. If you're looking at a specific point source discharge, maybe you have sites just downstream of the discharge and just upstream for a reference location. It will really depend on what you're trying to accomplish with your monitoring. But you also need to take into account, of course, accessibility, safety, and the capacity of your organization. So how many monitoring sites can you effectively monitor given the people power that you have? When will you monitor? So this is like what time of year, with what frequency. Will you target special weather conditions with your monitoring? And again, this will be dictated by your monitoring question. So if you're looking at, again, sort of the general watershed health side of things, and you're monitoring, benthic macroinvertebrates, maybe once a year or twice a year might be the frequency you target. If you're looking at something like, other water quality parameters, maybe you're monitoring monthly or quarterly. With the road salt case study, we're looking at special weather conditions, so trying to monitor during those snow melt conditions. If you want to look at cold water habitat suitability for trout, you'll want to monitor temperature during the summer when it's most when temperatures are likely to be most stressful for cold water fish. So it all comes back to your question. And finally, what are your QA/QC measures? So what kind of training requirements will you institute? How will you take care of your equipment? Will you do like replicate samples, or will you send samples to labs intermittently to check your field measurements? And how will you document your procedures? Again, a lot of this is supported by MiCorps, but it's also, I think, useful for folks to have an understanding of how to go through this process and develop these monitoring programs. And then finally, how will you present your data? How will you manage and present your data? So how is data recorded? Are you writing it on paper data sheets? Do you have some sort of smartphone app? Are you storing it in an online data repository, or is it on an Excel spreadsheet somewhere? And then how will you actually analyze? What kind of metrics will you calculate with your data? How will you visualize the data? Really thinking about these things in advance of starting your monitoring program is just going to set you up so much better for collecting data in a way that's efficient and that supports your intended use of the data. And then lastly, what are the tasks and who will do them? Whenever I start a new monitoring program, I try to actually list out literally every task in a timeline that will go into completing that program. Just to, make sure you have a full view of like everything that needs to be done. And then you can start to distribute roles like, a volunteer trainer or an equipment manager or data entry, things like that. And so, like I've said a few times, programs like MiCorps provide support for many of these tasks and many of the parts of this process. So that's a very short introduction to this process. Like I said, I'd be happy to share resources that I use this is based off of. But I just want to end with thanking you all for the time and effort that you spend in your volunteer monitoring work. It's without folks like you, we would have a fraction of the data that we do have that really is just pays so many dividends in understanding and better managing our resources. And, something I've found through the years in managing these projects is that though we may be collecting data for a particular reason, we don't know how this data will be used in the future. And I'm seeing data that, I was involved in collecting, 10 years ago that's now being used for other purposes that I never even envisioned. So this data, both for, sort of the short-term benefit and long-term, it's just so important, and it wouldn't be collected if it wasn't for programs like this and for volunteers like you. So thank you. That's all I have. I'm happy to take questions, and thank you so much for inviting me out today.
Thank you so much, Jake. That was really great and very, very interesting. And we definitely have some questions that have come in. So let you get your drink of water, catch your breath for a second, and pose some of those questions for you. So Ron asks, does TU collaborate with local Northwest Michigan tribes like the Grand Traverse Band or the Little River Band in their efforts to reestablish Arctic grayling?
So I personally am not involved in the grayling project, but I can say that our Michigan Council has been involved in that in some capacity. So it's definitely something that TU has been involved in, but I can't speak personally in a lot of detail just because it's not been something that I've been a part of.
Sure. All right. The next question from Rex: what are the water temperature ranges over a 12-month period that will support trout?
So here, let me go back to that slide. It depends on the trout species. Brown trout can handle a little bit warmer water temperature than brook trout. USGS uses a threshold so the metric that you're seeing here is maximum weekly average temperature. So basically this is the highest average temperature for any 7-day period throughout the year. So basically you're averaging every 7-day period, Monday through Sunday, Tuesday through Monday, Wednesday through Tuesday, throughout the whole year. And you find the maximum of that. And so there are some thresholds for cold water habitat suitability for trout for that metric. USGS uses 23. So you can see that basically once it hits 23 degrees Fahrenheit or Celsius rather, it starts to get into the unsuitable range. Here in Michigan, when I'm working with temperature data, typically I say, and this is with some wiggle room, if it's a maximum weekly average temperature of less than 66 degrees Fahrenheit is fantastic. Less than 70 is good. Less than 73, I would say, is sort of marginal. And once you get above 73, you're getting into unsuitable temperatures for trout species. So, yeah, that's how I would answer that.
Thanks. That's great. Another question from Daniel. Does TU's stream aquatic macroinvertebrate data feed into MiCorps database?
Yeah, we actually have our field crews. So we hire seasonal field crews each summer, and a big part of what they do is conduct benthic macroinvertebrate assessments, and that does go into the MiCorps. We use MiCorps protocols, and it goes to the MiCorps database. And I know that we've supported we've worked with volunteer groups in the Rogue River watershed as well to do benthic macroinvertebrate monitoring, and I've kind of had in the back of my mind to expand that. It just hasn't happened yet in the other watersheds. But yep, we do feed into MiCorps.
Great. Yes. And I can confirm that is the case. It's great to have that partnership for sure. Jason just wanted to share a comment. He's at the Huron River Watershed Council in Ann Arbor, and he noted that our local TU has been amazing to work with. We collect and share different data with each other. We collaborate on grant applications, and we cross-pollinate volunteers and experts. So another example of a really great collaboration with TU and other groups around Michigan. I had a question for you, and actually had a few, and I could probably talk for hours about this stuff. But one question that I had, we think a lot about our data audiences, as you mentioned them, like who is going to see this data. And I'm curious to hear from you a little bit about how TU communicates their study results to the various data audiences. I'm sure some audiences are more technically savvy than others. And, what have you seen work really well to share your results? Or if you have any examples of something that didn't work well?
If there's any way for me to effectively communicate data results in a map, that's how I do it. I avoid especially I work with broad audiences of varied backgrounds in almost everything I do. And graphs and all that are necessary in many cases, especially when you're working with like time series data. But anytime I can assimilate that time series data into a single metric, like for the example, a good example of this is this maximum weekly average temperature, and display that in a map, I find that's the way I like to communicate data results. And so, for example, in the White River watershed where I do a lot of work, I mentioned that I've spent a lot of time pulling together various data sources to develop basically it's kind of like a decision support tool, and it's an interactive online map where I've grabbed different data metrics and put it into this sort of map form that's, I think, a lot easier to understand and to contextualize it into the watershed landscape. And so tools like ArcGIS Online are free to use, and if you have the gumption, they're not terribly difficult to figure out. And so that's how I like to do things with maps as much as possible.
I'm excited that you mentioned that. That's one of the things that we're hoping to roll out for the MiCorps website in the coming year is much improved mapping. Well, I can't say improved. We don't have maps now. So adding mapping and GIS to our website. So when you go in to look at our data, it isn't just necessarily tables of numbers. You can look at it in a graphic form, a visual form that includes maps. And so we're really excited to move in that direction too. So it's great to hear that you find that works really well as well.
Awesome.
Yeah, I wanted to comment. We've got another question from Ron. Great job, thanks. And on a personal note, did you get to fly fish Spring Creek when you were at State College?
I lived about maybe like a 5 minute walk from Spring Creek for several years, and so I fished Spring Creek a lot. Love the sulfur hatch on Spring Creek. That's where it's at.
That's great. That's great. And I would also mention, you mentioned, a lot of your experience working with Alarm out in Pennsylvania and all the great work they do out there. And I'll note that to give a little MiCorps history connection, Julie Bastine from Alarm, who's their director, she was actually our keynote speaker at the Ram Center in 2014. Oh. So you're following in her footsteps as our keynote speaker today at the 2022 MiCorps conference.
Cool. Well, yeah, Julie's awesome. I learned a lot from they were our close collaborators in the shale gas monitoring program. And so as I was cutting my teeth in the volunteer monitoring world, Julie was a mentor for me. So
Great. All right. Well, I want to keep us on schedule. We've actually gotten through the questions that were in the chat. Jake, maybe if before you sign off, if you could throw your email address or contact info into the chat, if people
Sure.
are interested in following up with you, maybe have a question that takes a little more time to work through, they can reach you that way. So thank you so much for all of you joining us today. I just have a couple of wrap-up comments to make. I want to thank all of our team, our MiCorps team, for all their work they put in for putting this together behind the scenes and out in front of you all today. I particularly want to thank Jake and our other guest speaker, Joe Rathman, who spoke about native mussels with us today, for taking the time to be with us and making the quick switch to online. I also want to thank all of you, our volunteers, our program leaders, people who care about Michigan's lakes and streams. I think that that's been so valuable, and we value you very, very much. And in the theme of thanking people, I know I was asked to give a little shout out for somebody who's in the audience right now, Joyce Durdell, who's with the Little Manistee Watershed Conservation Council. I'm not sure she's still with us, but she actually emailed me this morning, and she wants to recognize Chelsea Cooper. And I think Chelsea is still with us today. I think I see her name in the list. And she said, "Oh man, I should have spoken up when we were, recognizing volunteers this morning, but she didn't do that." So, Chelsea, I think you're here, right?
Yep, I'm here.
All right. Well, I'm going to read what Joyce had to say, Chelsea. And, if you might blush a little bit when you hear this. Here's what Joyce had to say. Chelsea is responsible for revitalizing and updating the Little Manistee River MiCorps participation. I'm with the Little Manistee Watershed Conservation Council, and we have been partnered with the Manistee Conservation District and the Mason Lake Conservation District. Our watershed group supports those districts to use interns to help with stream monitoring for the last 3 years. Chelsea coordinated most of the work and mentored our new interns as they started into water monitoring projects on both lakes and on streams. She is a phenomenal young woman, and we and this conservation districts have benefited greatly having Chelsea lead the team. So I wanted to pass that along. I love being able to share that gratitude and thanks as we wrap up this conference.
Yeah, thanks so much.
You're welcome, Chelsea. I know you've been working hard. So again, thanks everyone for being here today. Don't forget to fill out that evaluation. I'm going to put that link in the chat again right now. It'll only take you a moment to fill it out, and then it'll be done, and you can ignore any other pleas for filling out that evaluation. So please do that. It's the feedback we need to improve our events and to better serve your interests. So thanks again. We're almost at 4 o'clock, and so that's going to adjourn the 2022 MiCorps conference.